Dealing with integrals that involve secant and tangent is very similar to dealing with the sine and cosine integrals. But we've got a couple of rules that we'll use and a couple of other things we need. We might need this identity, tan squared x plus 1 equals secant squared x. And the other thing that we need is something you should remember from Calc 1. The derivative of tan is secant squared, and the derivative of secant is secant tangent. So these things will come in handy. All right, let's look at this first example. Or actually, before we do the example, let's look at the rules over here. If the power of secant is even, then you let u equal tan x. If the power of tangent is odd, you let u equal secant x. If both of those are true, you can pick either one. And if neither of those are true, then you're down here and things are going to be more complicated. So let's do this example here. This first example says secant squared times tan cubed. So power of secant's even and power of tangent's odd. I actually want to do this one both ways to show you that you get the same answer, or at least equivalent answers. So I think the easier way to do this one, let's do that first, is to let u equal tan. Because if you let u equal tan, then du is going to be secant squared x dx. And you can do this one almost immediately. The tan cubed becomes u cubed, and secant squared x dx just becomes your dx. And you're left with 1/4 u to the 4th. And that's 1/4 tan to the 4th x plus c. That's definitely the way to go on this problem. But let's do it the other way just to see what we get and to see that they're equivalent to each other. So I'm going to, let's see, I'll do it in purple so that it's different. All right, so in purple, I'm going to let u equal secant. And du is going to be secant x tan x. All right, so I'm going to rewrite the integral secant squared like this. And now what I'm really, the way to think about this is we're saving out a secant x tan x. So I'm going to rewrite this as secant x tan squared x, and then secant x tan x dx. So I'm doing that way. Let's see, this secant becomes u. This tan here, it gets replaced with secant squared minus 1. So that's u squared minus 1. And then secant x tan x dx is just my du. So I can rewrite this as, let's see, integral of u cubed minus u du. So that's 1/4 u to the 4th minus 1/2 u squared plus c. That gives me an answer of 1/4 u with secant. So secant to the 4th minus 1/2 secant squared plus c. So we can do this two different ways, and the different ways give us things that look like different answers. So I want to show you that these are the same. Now we could go through a bunch of trig identities and stuff and try to show that these are equal. But a better way to do that is to graph it. So I'm going to put these into Desmos. So let's see, one of those was y equals 1/4 tan to the 4th x. Let's see, does Desmos graph that? It doesn't like that. tan x to the fourth. Okay, so we get a bunch of u's over there. The other one was y equals 1/4 secant to the fourth minus a half secant squared. And the question is, are these two things the same graph? Well, just looking at it, if we zoom in, they're not exactly the same. But the thing is, they differ by a constant. So I'm going to put plus c on the end here. And I should be able to slide this around. And let's see, somewhere between 0.3 and 0.2. So if I move this somewhere in here, I should be able to get them where they're exactly on top of each other. Yeah, 0.25. So yeah, they the two graphs there, if we graph them, they differ by 1/4, and that's okay because when we do these integrals, we get the plus c on the end. So differing by a constant is fine. So if you did this problem, either one of these answers is correct. You could call it this or you could call it that. And that's kind of an important thing to keep in mind if you do a problem and you look in the back of the textbook and it's, like in this case, it's written in secants instead of tangents or vice versa. It's good to, be aware that sometimes you can have the correct answer, but it's written in a different form.